It takes a close look at potential health concerns linked to wind turbines. Our source material is essentially a paper, maybe a presentation, from Dr. Stephen Crozier. He's a family medicine specialist and was a municipal chief medical officer over in Norway.
That's right. And, Dr. Crozier wasn't initially focused on this at all. He apparently got drawn in because of local protests on his home island, Frøya, about a planned wind farm.
Ah, okay.
Yeah, and he was actually quite skeptical at first. He thought the claims about infrasound causing health problems sounded, well, a bit far-fetched.
Hmm.
But his perspective started to shift as he began his own investigation.
Right. So our mission here is really to explore Dr. Crozier's material, pull out the key insights for you listening. Things like, what did he actually investigate? What did his sound measurements show near these wind farms? And what health issues were being reported by residents there in Norway? Plus his, let's say, critical view on the public health response.
Exactly. It's quite a deep dive into his findings and perspective.
Okay, let's unpack this then. What exactly is wind turbine infrasound, according to this source? And why is the author making a point of highlighting it?
Well, the source defines infrasound pretty simply. It's low-frequency air pressure waves, stuff you typically can't actually hear. And it points out that, awareness of potential infrasound effects isn't exactly new. There were international meetings way back in the 70s, and again in 1980 in Aalborg, that discussed these effects and even suggested some early exposure criteria.
So this has been on the radar for a while.
Yeah, and Dr. Neil Kelly's work from the early 80s on wind turbine noise assessment is also mentioned as important background.
Okay. But the author here thinks there's something specific about wind turbine infrasound.
That's the core argument. While we have infrasound all around us, from traffic from nature that tends to be more random broadband stuff, wind turbine infrasound, according to this paper, is potentially unique.
Unique how? What makes it different?
The source says its signatures are made up of what the author calls blade pass harmonics.
Blade pass harmonics.
Okay, think of it like a repeating pulse, a rhythmic pressure wave, every time one of those huge blades swooshes past the tower. And crucially, he says it has high peak-to-trough levels.
High peak to trough. Can you break that down a bit? What does that mean simply?
Okay, imagine a wave of air pressure. Most sound might be like gentle ripples on water. The author is saying wind turbines with these blade pass harmonics create pressure waves that have a particularly big swing.
A big swing.
Yeah, they go from their highest pressure point, the peak, to their lowest pressure point, the trough, very sharply, with a large difference between them, even if the average sound level seems low or it's in that non-audible range. It's this specific characteristic, this big swing or high peak to trough level in these repeating pulses that the author thinks makes it potentially different and maybe more impactful than just random background infrasound.
And the author feels that a lot of studies might be missing this specific point.
It's exactly. He's quite critical of a specific 2020 study. The title was something like, "Infrasound does not explain symptoms related to wind turbines." His view is that its method, which involved a short 10-minute listening test done 2.5 kilometers away from turbines, probably at pretty low exposure levels, is just, well, totally inadequate.
Inadequate for what?
For assessing what it's really like for people living closer, exposed 247 to this specific type of infrasound, potentially at much higher peak levels. He notes other research suggests levels can hit 95 dBs or even higher sometimes.
Right. That's a big difference from a short test.
Yeah, and he uses this really good analogy for that study's design.
What was it?
He compares it to testing if smoking is harmful by getting non-smokers to smoke just 2 cigarettes for only 10 minutes.
Okay. Point taken.
Yeah, his point is it just doesn't reflect the continuous nature or the specific kind of infrasound exposure that residents near these large wind farms might be experiencing day in, day out.
Right. It's not just about loudness, it's about the character of the pressure wave and the long-term exposure, according to his analysis. So, given that understanding, what did he actually find when he started doing his own measurements near wind farms in Norway?
Well, he conducted these simultaneous sound recordings in late 2019 and early 2021 on 2 islands, Hitra and Frøya.
What was the setup like? How did he measure it?
He used specific equipment, Sam scribed the second recorders, and had 2 microphones running at the same time for each location. One was placed outdoors, about 2 meters from a house, and the other one was indoors, specifically in the bedroom, positioned just 15 centimeters above the pillow.
Okay, right near where someone would sleep.
Exactly. And both mics were pointed towards the wind turbine farms. He wanted to capture the sound both outside and, crucially, inside, where people actually live and sleep.
And which wind farms were nearby?
The main ones were Hitra 1, which was commissioned way back in 2004 using Siemens turbines. And then Hitra 2, which started up much more recently in autumn 2019. Hitra 2 uses these newer, larger Vestas turbines. They have a significantly larger blade sweep area, over 10,000 square meters, compared to less than 6,000 for the older ones.
And larger blades generally mean?
Generally mean potentially more significant infrasound generation, as the source notes.
Okay. And how far were the houses he recorded from these farms?
The houses on Hitra where he recorded were located 10 kilometers away from both Hitra 1 and Hitra 2.
10 kilometers? That sounds pretty far, actually.
It does. And he also did recordings on Frøya, which were even further, about 16 kilometers from the Hitra house he measured, and 20 kilometers from the actual Hitra wind farms.
Okay, so even at 10 kilometers distance, what did the recordings show? Did he find those high peak-to-trough levels he was talking about?
He did. And the findings presented in his tables are really notable, especially the difference between outside and inside. If you look at samples of the outdoor peak-to-trough values, they might seem, well, relatively low, maybe 14 dB at 6 hertz on Hitra, for example. But then you look at the bedroom recordings.
And that's where things changed.
That's where the numbers jumped significantly, according to the source. The bedroom peak-to-trough values were often much higher, like 29 dB at 6 hertz on Hitra, 28 dB at 6 hertz on Frøya. Similar high values at other low frequencies, too.
Higher inside the bedroom than outside. How does that work?
Well, the author notes that building structures themselves can sometimes resonate with these specific low frequencies. They can sort of trap and amplify them indoors, which might explain why the levels of this specific characteristic, the peak-to-trough swing, were often higher inside, in places like bedrooms, than just outside the house.
So the place where people are most vulnerable, maybe especially when sleeping, might actually experience higher levels of this specific infrasound signature.
That's what his measurements at these specific locations suggest, yeah. He even noted some peak upper-level recordings reaching 116 dB outdoors and 109 dB in the Hitra bedroom during certain periods, and 111 dB outdoors, 99 dB indoors at the Frøya house.
Wow, those sound like high numbers, even if it's infrasound.
They indicate very intense pressure waves at certain times, yes.
And he thinks these measurements, even at the Hitra house, weren't just coming from the closest turbines, Hitra 1 and 2.
Correct. This is where it gets really interesting, his discussion about potential long-distance transmission. While Hitra 1 and 2 are the obvious suspects for the effects at the Hitra house, 10 kilometers away, the author suggests that two other large wind farms, Frøya and Røn, which are located 70 to 100 kilometers away.
70 to 100 kilometers? Seriously?
Yes. He suggests they likely also contribute to the infrasound signature he was picking up, particularly under certain conditions.
How is that even possible over such distances?
Well, he points to factors like the wind direction during his recordings, which was east-northeast, and specific weather conditions, particularly something called temperature inversion, especially over water, combined with downwind propagation.
Temperature inversion, like a lid on the atmosphere.
Kind of, yeah. A layer of warmer air traps cooler air below it. This can act like a channel or a duct for sound waves, especially low-frequency ones. It allows them to travel much, much further than usual, especially over a flat surface like water.
Okay.
And he notes that these distant farms, Frøya and Røn, use similar large Vestas V117 turbines to the ones at Hitra 2, so they're capable of generating significant low-frequency sound.
Interesting. And the source mentions something else about those specific farms.
Yeah, just as background context, it notes that these are the same wind farms, Frøya and Røn, that were involved in that Norwegian Supreme Court ruling back in October 2021.
The one concerning Sami human rights and reindeer herding.
That's the one. The source just mentions it factually.
Okay, so we've got measurements showing these specific high peak-to-trough infrasound levels, particularly indoors, potentially traveling long distances under the right conditions. What did the author find regarding actual health reports from people living near these wind farms?
The source presents two specific cases in some detail. These are from people living 10 kilometers from the Hitra 1 and 2 wind farms, near where he took those measurements.
Okay, tell us about those cases.
The first case involves a person who started experiencing serious sleep disturbance right after the newer, larger Hitra 2 farm began production in autumn 2019. Their symptoms included feeling like the rooms were rumbling or booming, particularly when the wind got above 5 meters per second.
To the point where?
To the point where they felt they actually needed to leave their house just to get some rest. They described searching for the source of the noise but couldn't find it, which is pretty consistent with being low-frequency sound or infrasound.
And what's interesting about their history?
What's particularly notable, the source points out, is that this person had lived near the older Hitra 1 farm for 9 years without any problems at all. They were even initially favorable towards wind power development. Their issues began specifically when the larger Hitra 2 turbines came online nearby.
Okay. And the second case?
The second case is about a person in their late 50s, also living 10 kilometers away. They developed recurring atrial fibrillation in 2021.
That's a serious heart rhythm problem.
Very serious, yeah. They needed multiple medical treatments, electrical cardioversion, ablation procedures. But the crucial point highlighted in the source is the pattern. Their symptoms, the atrial fibrillation, recurred when they were in the house.
And when they left.
The symptoms consistently stopped or improved when they vacated the house.
Wow. Did the author find anything else notable about these two individuals?
Yes. He notes that his recordings showed both of their houses had that similar pattern of high peak-to-trough infrasound levels in the bedroom. He also mentions that both of these people self-identified as highly sensitive persons, or HSPs. He notes this is estimated to be about 1 in 5 people in the general population.
HSP. And the author makes a point about that.
Yeah, he kind of raises the question, if a significant health issue, maybe linked to an environmental exposure, affects a minority of the population for, say, 20%, shouldn't that still be considered a major public health concern? Shouldn't that warrant investigation?
It's a fair question. Now, it's really important, isn't it, to be clear about the author's stance on what these two cases actually mean?
Absolutely crucial. He is very, very explicit about this in the source. He states clearly that these two cases on their own prove nothing about cause and effect.
Okay. No definitive proof.
No. But, he says, they do give reason, in fact, strong reason, for conducting further, proper, large-scale health studies of residents who live within, say, 10 kilometers of these large wind turbine farms.
So he sees them as potential signals, red flags maybe, not conclusive evidence.
Exactly. Signals that warrant a closer look.
Okay. Beyond these individual cases, did he look at any broader community-level data?
Yes. The source also brings up the Tysvær Health Survey. This was conducted in 2023. It was actually commissioned because health complaints arose in that area after the Tysvær wind farm started production in 2021. It's apparently only the second health survey specifically done near a wind farm in Norway.
And what did that survey find?
Well, the findings presented from it are quite striking, according to the source. When compared to reference groups, the percentage of residents in Tysvær reporting various health issues was significantly higher.
Like what, for instance?
Okay, for example, sleep disturbances, reported by 89% of the Tysvær residents surveyed versus 51% in the reference group.
89%, that's huge.
It's a massive difference. Yeah. Muscle pain was 70% versus 53%. Dizziness was 55% versus 39%.
Still significant gaps.
Yeah, and maybe one of the most notable findings was headache or migraine. That was reported by 41% in Tysvær compared to just 21% in the reference groups. Almost double.
Wow.
The survey also found high levels of annoyance from audible noise, and a large majority, 63%, were non-favorable towards the wind farm, compared to only 17% in favor.
Did the author add any caveats about that survey?
He does make a methodological point. The survey had a 53% participation rate. He notes it's possible that if people who weren't experiencing symptoms were less likely to respond, this could potentially inflate the relative numbers for the health complaints among those who did respond.
Right, a potential participation bias.
Exactly. It's something to keep in mind.
Yeah.
But even so, the differences reported are pretty substantial.
Okay, so the author presents these measurements showing specific infrasound characteristics, especially indoors. He has case reports, survey data suggesting potential problems. How does he hypothesize this non-audible sound might actually be affecting people physically? What are the potential biological mechanisms?
Well, he touches on some possibilities and references some supporting research. For example, he mentions recent work looking at potential impairment of the endothelium, that's the lining of our blood vessels, and also microcirculation.
How would infrasound affect blood vessels?
The idea mentioned is something called irregular mechanotransduction. It's a technical term.
Okay.
But the basic idea is that these physical pressure waves, the infrasound, could be disrupting the normal mechanical signals within our cells, signals that help regulate how cells function. This could potentially affect blood flow at a very small micro level.
Interesting. Anything else?
He also points to some historical work. He shows a figure indicating that the recommended maximum pressure limits, or MPLs, for low-frequency sound and infrasound in both workplaces and homes have actually trended significantly downwards from the 1970s up to the year 2000.
So we've been lowering what's considered acceptable over time.
It suggests a growing recognition over decades that these low frequencies might have effects even at levels previously thought to be safe.
And what about the specific type of wind turbine infrasound he measured? The one with the high peak-to-trough levels, the blade pass harmonics. What's his hypothesis for its potential biological impact?
Okay, the hypothesis presented in the source is that those large, sharp swings, the high peak-to-trough levels, might generate more hysteresis in our cells and organs compared to just a constant, steady level of infrasound, even if that steady level is also high.
Hysteresis, what exactly does that mean in a biological context?
Think of it like, imagine pushing on something flexible, like a spring or maybe a cell membrane. If you push and pull smoothly and gently, it responds pretty predictably.
Right.
But if you push really hard one way, then suddenly reverse direction and pull hard the other way, especially if it's a jerky movement or a really big swing, it can cause a kind of lagging response. The material doesn't quite keep up, or it experiences more stress than it would under steady pressure.
Okay, like a delayed reaction or extra strain.
Exactly. The author suggests these sharp, high-amplitude pressure swings from the turbines might be causing a more disruptive, lagging effect, this hysteresis, at the cellular level.
And he links this idea to specific health conditions.
Yes, he specifically connects this concept of hysteresis potentially affecting myocardial cells, that's heart muscle cells. He suggests it could contribute to things like atrial fibrosis, which is scarring in the heart tissue, and arrhythmias, like the atrial fibrillation seen in one of the case studies.
Is there any research supporting that link?
He references a 2021 study done on rats titled Infrasound Exposure Promotes Development of Atrial Fibrosis in Rats, as relevant research suggesting that infrasound could indeed have direct physical effects on heart tissue.
Okay, so he's presenting a picture. Measurements, case reports, survey data, and some plausible, though maybe not fully proven, biological mechanisms. How has the public health system in Norway, according to him, responded to these concerns and his findings?
Well, according to the source, his experience dealing with the main public health body, the Norwegian Institute of Public Health, or NIPH, has been, let's say, frustrating for him. He describes a meeting he had with them way back in January 2020. He presented his recordings, which showed high infrasound levels near a different wind farm where residents were reporting adverse reactions.
And what did he ask the NIPH to do based on that?
He basically appealed for them to initiate official health surveys and proper sound monitoring, including infrasound for residents living near these wind farms.
And the response was?
She says his appeal was dismissed. The reasons given, according to the source, were things like a lack of funds, and also apparently a dismissal of the idea that the industry should have to prove the safety of their installations first. He also points out what he sees as inconsistencies in the NIPH's public statements. For instance, he contrasts a statement on their website from May 2022, which said something like, although neither infrasound nor low-frequency sound are specific to wind turbines.
With his own findings.
Exactly. With his view, based on his measurements, that the prominent blade pass harmonics actually do make wind turbine infrasound quite specific and potentially different in its effects.
Any other points about the NIPH communication?
Yeah, he also notes that while the NIPH website mentions an older survey from 2015, which showed high noise annoyance near a wind farm, it apparently doesn't mention the more recent 2023 Tysvær survey, the one that reported higher rates of various actual health complaints, like sleep disturbance and headaches.
Okay, so this leads him to a pretty strong critique of the regulatory situation in Norway as presented in the source.
Yes, very much so. He highlights several key regulatory gaps as he sees them.
What are the main ones?
Okay, according to the author, there are no mandatory requirements for wind farm operators to measure sound levels, specifically including infrasound, inside people's homes after the turbines are built. When measurements are taken, he claims the results are often kept confidential, hidden behind arguments about proprietary or competitive issues.
So lack of transparency.
Yes. And crucially, he emphasizes there are no set legal limits for infrasound levels inside residences in Norway. He also feels there's a significant lack of knowledge and maybe awareness among local chief medical officers regarding sound pollution issues, particularly from sources like wind farms.
And his core point about safety.
His core point, which he keeps coming back to, is that the wind industry isn't required to actually prove the safety of these newer, ever larger turbines, which are known to produce higher levels of infrasound. He argues that the authority that grants the licenses for these farms, the NVE, lacks sufficient public health expertise and simply relies on what he calls the NIPH's lackluster approach.
He uses some pretty strong analogies to make this point, doesn't he, about proving safety.
He does. He compares the situation to, say, licensing new cars or approving new pharmaceutical drugs without demanding rigorous safety testing and proof beforehand.
And he mentions a situation in Denmark.
Yeah, referencing other sources, he mentions that the Danish environmental agency, DEPA, apparently proposed specific infrasound limits back in 2011. But those proposed limits were reportedly withdrawn after lobbying from Vestas, a major turbine manufacturer, apparently due to concerns about the economic impact.
Interesting. Now, circling back to that idea of highly sensitive persons, or HSPs, he makes a strong argument about that in the context of public health, right?
He does. He argues forcefully that even if, hypothetically, it's primarily the estimated 20% of the population who are HSPs who report problems first, it's still a very significant portion of the population, 1 in 5 people. He basically asks, why wouldn't an issue potentially affecting up to 20% of people be considered a major public health priority that requires urgent investigation? He compares it to other public health concerns that might initially surface in a specific minority group.
So what's the alternative approach he advocates for?
Well, he refers to a recommendation from an article he co-authored in 2021. It suggests that thorough, independent studies conducted by experts across all the relevant fields, acoustics, public health, medicine, industrial hygiene, the lot should be mandatory before any licenses for new wind farms are even awarded.
Assessing all potential effects together.
Yes, assessing all potential negative effects, noise, infrasound, visual impacts, everything collectively up front.
And he talks about the challenges his group has faced trying to push for this.
Yeah, he describes the difficulties faced by the public health committee he's part of within an organization called Mutven Norge. They've apparently met with various government directorates and agencies in Norway. He says these agencies often acknowledge the issues people report: the noise, infrasound, light flicker, shadow flicker, even grief over landscape changes, property value loss. But, he claims, they then say they lack the specific competence or jurisdiction to deal with them. Effectively, he says they're passing the buck. And meanwhile, he states the NIPH, the main public health body, hasn't responded to their attempts to engage.
He draws a parallel to other historical public health issues.
He does. He draws an analogy to the long delays in regulatory action on hazards like asbestos and tobacco smoke, where, definitive action lagged decades behind the accumulating scientific knowledge about the harms.
And he has a suggestion for how to fund the needed research.
As a practical idea presented in the source, he raises the possibility that some of the substantial financial proceeds generated by the wind turbine industry itself could potentially be earmarked to fund this crucial independent research and the development of proper guidelines and safety standards.
Okay, so based on all his findings, his critique, what's the public health approach he ultimately recommends? He mentions the precautionary principle.
Yes, invoking the precautionary principle, the idea that you should take preventive action in the face of potential harm, even without absolute scientific certainty. Based on that, his recommendations, as presented in the source, are pretty clear and direct.
Sure.
First, mandate rigorous, independent infrasound measurements inside homes near existing and proposed wind farms. Second, establish specific protective legal limits for infrasound levels within residences, perhaps something like what the Danish agency DEPA initially proposed. And third, impose a moratorium, a temporary halt on building any new large wind turbines closer than, say, 10 kilometers to residential areas until these comprehensive studies are done and proper safety standards are actually established and enforced.
Right. So this deep dive into Dr. Crozier's source really lays out a compelling tension, doesn't it? On one hand, you have this medical professional's investigation based on his own specific measurements and the health reports he's gathered or aware of, suggesting potential links between a very specific characteristic of wind turbine infrasound, those high peak-to-trough blade pass harmonics, and real health issues reported by people living near these farms in Norway.
And on the other hand, as presented in the source, you have his perception of a regulatory and public health system that he sees as being slow to act, or maybe lacking the necessary competence or perhaps the political will to set clear standards, to mandate the needed independent research, and critically, to require the industry to definitively prove the safety of these ever larger machines. All this despite the specific measurements, the case reports, and the survey data that he argues strongly point towards potential problems needing urgent attention.
It's clearly a really complex issue. It's not just about the sound itself, is it? It's about how that sound interacts with the environment, behaving differently indoors versus outdoors, how it travels over distances, how weather affects it, and then these deeper questions about potential subtle cumulative biological impacts and whether some individuals might just be more sensitive than others.
Exactly. Lots of interacting factors.
So here's where it gets really interesting for you listening. What specific aspect or finding from this deep dive into Dr. Crozier's source material stands out most to you? What grabs your attention? And maybe a final, more provocative thought for you to consider, building on everything we've explored here from the source. If it turns out that the effects of wind turbine infrasound can indeed travel over significant distances, and if they could potentially have these subtle, maybe cumulative biological impacts, how should communities and policymakers realistically balance that urgent, undeniable need for renewable energy development with the fundamental public health principle of taking precautionary measures, measures to protect the health and well-being of people living nearby, especially when specific, agreed-upon safety standards for this particular type of exposure aren't yet widely established or rigorously enforced?
That's the million-dollar question, isn't it? How to strike that balance responsibly.
It certainly is. Thank you for joining us on this deep dive into the source material.